Okay, people, homework 2, here we go, rational equations. So these are going to look like linear equations with fractions, but you'll notice that in the denominator, we will have a variable. So in this case, we have 4 over x minus 2 over 5 equals 6 over x. We're going to use the same method, though, that we did with solving linear equations with fractions. We're going to look for a least common denominator. Some people's brain works a little bit differently, so I'm going to do this very first one just slowly here. I'm looking for this x to cross out. So I'm going to place this x in the numerator by multiplying it. Now that's fine, I can do that, and it's going to do x over x, which is 1, and it's going to eliminate, which is what I want. I can do that only as long as I also multiply x times the numerator and every part of the equation. Okay, and then, so that will fix this fraction right here. But let's look at the second term. This one doesn't have an x in the denominator. Instead, there's a 5. So I want to use the same thought process here, and I want to multiply by 5 in the numerator so that this 5 divided by this 5 gives us 1. But again, I can't only multiply by this term. I have to multiply times this term and times this term. So I went around the long way, but I have found that my least common denominator, the thing that will clear my fractions, is 5 and x. So 5x. Because that x that we used at the beginning is also going to cancel out this x from this term, and it's going to clear my fraction. So my LCD is 5x, so I've multiplied each term by 5 and by x, and that's going to clear my fractions. So let's go ahead and do that. Right here, the x's, x divided by x is 1, so we have 4 times 5, which is 20. And here we have 5 over 5, again that's 1, leaving us just 2 times x. And in this last term, x over x is 1, leaving 6 times 5, which is 30. All of these problems, once you clear the fractions and you have a linear equation, then you just use your properties and you can isolate your x. So minus 20 on both sides, leaving negative 2x equals 10. Don't make a mistake and lose this negative. It happens all the time. This negative belongs to this 2. They need to be rewritten together, and then you also need to bring it with you when you divide, because we're trying to isolate x here. Don't lose it. It happens a lot. 10 over negative 2 is negative 5. Now, for these problems, you have to check. I know the last video I kind of got lazy. I didn't continue to check, but these you must check, because if I get a number divided by 0, then my answer might not actually be a solution. It's called an extraneous solution. So I'm going to plug this back in. I have 4 over negative 5 minus 2 over 5 equals 6 over negative 5. Okay, so over here, this negative 5, it can go out front, giving us negative 4/5 minus 2/5. So negative 6 over 5 equals the same thing, negative 6 over 5. So both sides of my equation are balanced. My check worked out. X equals negative 5 is an appropriate answer. Okay, so I had a constant and I had a variable in the denominator. I had to multiply by both of them. Let's take another look here. What happens, let's do this one. 2 over 5x plus 1/3 equals 2 over x minus 3 over 5. Okay, so you could use the same trick that we used over here, multiply by 5x, multiply by 3, and then continue on from there. Or we can just look at the denominators and find their commonality here. What can 5 and 3 both divide into? Well, they can both divide into 15. 15 divided by 5 is 3. 15 divided by 3 is 5. So if the smaller number doesn't divide into the bigger number, multiply the two numbers to get your LCD. So 3 times 5 is 15. But notice here that we also have x in the denominator, so I have to account for that x, so that when I multiply by that, I clear the denominator. So what I'm going to do, and I'll rewrite this for you in a different way this time, I'm going to distribute 15x to this whole problem. So here's another way to see that. That means I'm going to multiply 15x times each one of these numbers in the numerator. Now, you can multiply and then divide. So 15 times 2 divided by 5. Or you can divide and then multiply. It doesn't matter, because 15 divided by 5 times 2 is going to give you the same answer. So 15 times 2 is 30, divided by 5 is 6. And then the x's become 1, or they cancel out, so that leaves just 6. You can also think about it as reducing a fraction. 15 over 5 is 3. 3 times 2 is 6. We're also going to multiply that 15x here. So 15 divided by 3 is 5x. Going to multiply that 15x times this 2 to give us 30x divided by x, which is 30. And then 15x times 3 at the end, 45x divided by 5 is 15x. And I skipped a step there in the middle. If you need me to redo that problem, just let me know. And then we're going to combine like terms here. So I'm going to go with the let's make it positive plan and move my x's to the left and move my 6 to the right. Look, I'm doing it all at the same time. That's fine. You're advanced enough to be able to do that. Did I mess up my math? No, okay. Oh, lovely. Just reduce that fraction. Okay, and you can give me this fraction answer, or you can give me decimal. It doesn't matter. A quick way to see if it's going to work, if I plug in 6 over 5 here, that's 2 over 6. I can do that math. If I plug in 6 over 5 here, it's 10 over 5. I can do that math. So at no point am I going to be dividing by 0, so my answer works. Okay, let me find another problem. Okay, here we go. What if we have a binomial on the bottom? So x plus 1. 2 over x plus 1 plus 1/3 equals 1 over x plus 1. Now, I could find a common denominator and then cross multiply and solve that direction. But I want to work on eliminating the denominator, because people get the cross multiplying mixed up. They forget to combine, and then they forget how to cross multiply. So we're going to go ahead and use the LCD. Now, notice that this is x plus 1. They go together. I'm going to group them together so that I don't forget that. I cannot split this as 2x plus 2 over 1. That's witchcraft, not math, okay? I have to leave the x plus 1 together. Now, I need to represent the x plus 1 up here, and I need to represent the 3. So my LCD, I'm going to write it as 3, and then times the group x plus 1. Okay, and I'm going to show you how to do all this one. I won't do it in my head this time. I'll write it all out. We have 3 times x plus 1 times 2. So this numerator is still here. Plus 1 times 3 times x plus 1 over 3 equals 3 times x plus 1 over x plus 1. Now you can see what's going to start to eliminate. Remember, you have to keep the whole group. The x plus 1 goes together, so those cancel out. The 3's cancel out, and the x plus 1 cancels here. Okay, remultiply to fix your numerator. 3 times 2 is 6. My denominator is gone. It's perfect. That's what I wanted. 1 times x plus 1. Now, if there was a different number besides 1 here, I'd have to distribute that in here, but I got lucky. It's a 1, so I can drop my grouping. And over here, everything canceled out except for the 3. So here we go. I'm running out of space, so I'm starting to write funny. Sorry about that. Combine like terms, we got 7 plus x equals 3 minus 7 x equals negative 4. Now if I were to plug in negative 4 here, negative 4 plus 1 is negative 3. That's not 0. It's going to work. If I plug in negative 4 here, negative 4 plus 1 is still negative 3. So negative 4 is an acceptable answer. What's not an acceptable answer is negative 1, because that would mean we're dividing by 0, and we cannot do that. Okay. What happens if I have a quadratic function? Apologize. What happens if I have a quadratic function in one of my denominators? More often than not, if I multiply this grouping, n minus 2, times this grouping, n plus 1, and you can use the FOIL method or the box method to do that, we will get n squared minus n minus 2. So you can handle this problem two ways. You can start off by factoring this quadratic function. So that, remember, that means you need to split your variable, 1n for each fraction, and you want to find a number that multiplies to 2. Well, in our case, that only is 2 and 1. We need to make sure that they subtract, because this sign is negative. And this sign is negative in the middle, so that means my bigger number is negative. So we want them to subtract to be a negative 1. Let's check our math here. And look what happened. They happen to be the original function. I can do that the other way also. I can take my two binomials, multiply them out. I don't know why I made that box so big, because I'm crazy, I guess. Here we go. We can use the box method to foil it. N times n is n squared. N times 1 is n. N times negative 2 fills in this box, giving us negative 2n. And to fill in the last box, you multiply the numbers. So negative 2 times 1 is negative 2. So that is n squared minus 2, these two terms. And then to get the middle term, what we've done is added, see this plus sign here, 1 minus 2, or negative 2 plus 1 to give us the negative 1. So this quadratic function can be rewritten as n minus 2, n plus 1. Now that makes finding a common denominator a lot easier, because we can see that it is the common denominator, n minus 2, n plus 1. So I'm going to multiply the top by n minus 2, n plus 1. And I'm going to show you all the steps. So if you know what you're doing, go ahead and do it. See if you can solve it faster than me. I am just distributing out this least common denominator in the numerator here. We got lucky, all of these are 1s at the top, so it's going to make our problem easier. Whew, okay, now we can see that we can start to eliminate these groupings. So a fast way to do this is to multiply by each denominator And that also gives you what you're looking for.